So the next lecture regarding the data compression lecture series is we are going to study about the Markov model. Okay, just a review back regarding the previous lecture that we were doing the models, different types of models. First of all, we need models because we need to describe the source with the help of models. We are going to use the mathematical model for the data, and good model is needed for the data so that we can easily and in an efficient way estimate the entropy of the source. That we did in the last lecture, and we studied regarding the three models: the probability model, the physical model, and the composite model. The last model which was remaining is now we are going to cover, that is Markov model. Now let's see what is Markov model. When we define Markov model is a stochastic method. Now, when I say stochastic method means a random changing system. That means whenever I am going to predict future, the future is never dependent on the past. So when I say this is not depending on the past state, I cannot analyze the future state. So that is called as the stochastic method. Now, second point, we say that these models show all possible states as well as transitions, rate of transitions, and probabilities between them. So we are going to find out the state transition. That means how the model is moving from one state to another state, and the probability of transition, that is how they are moving. Next thing is Markov models are often used to model the probabilities of different states and the rate of transition among them. That is what I told you. We are going to model the probabilities different states and the rate of transition among them. And these models are used to describe these sources. Now, moving further, we need to understand that the model which is used in lossless compression is specifically called as discrete time Markov chain model. That means there are number of or various Markov models present, such as dynamic, hidden, etc., etc. So we are going to consider the discrete time Markov chain model for the lossless compression. Now, what does it say? It says that let xn be a sequence of observations. This sequence is said to have kth order Markov model if this equation is this: probability of xn minus 1 till xn minus k is equal to xn divided by xn minus 1, so on and so forth, kn minus k. Now, what does this represents? When I say k symbol is what? It is the knowledge of past k symbols. This is equal to the knowledge of entire history of the process. The values took on by the set xn minus 1 till xn minus k, and these are what? These are the state of processes. So we have different or number of state of processes present, which are represented by xn minus 1, so on and so forth, right? So I think we can easily get this with the help of an example we are going to see in further slides. Let's understand this concept. Next thing is when we create the Markov model in the first order. So first order Markov model defines that P, that is probability xn divided by xn minus 1. That means the probability of transition of xn state from state xn minus 1, that is equal to this. The above equation indicates the existence of dependence between the symbols. Now this is going to indicate the existence of dependence between symbols. If the size of source alphabet is L, then the number of states is L raised to the power K. So if the size of the source is L, then the number of states is L raised to the power K. Now in the output filter, how does it define? First of all, whenever they do not describe the form of dependence, we can develop different first order models depending on our assumption about the form of dependence between samples. If we assume that dependence was introduced linearly, then the output filter will be this, and it will include certain white noise that is represented by this symbol. Okay, so this model is generally used in developing and coding the algorithms for speech and images. That is the discrete Markov model. Now, I think let's make it more clear with the help of an example. Then you will get to know each and everything regarding this Markov model, that is discrete Markov model. See, when we define the Markov model, it can be expressed in two ways. What are the two ways to express this? First, it can be expressed in equation or in a graphical model. Graphical model typically uses circles. These circles indicates the states. These circles indicate the states. That means state is defined in the circle, and directional arrows to indicate possible transitional changes between them. The arrow will define the transitional change between the two states. The directional arrows are labeled with the rate of variable 1 for the rate. Now let's take an example of the binary image. Let's consider the binary image. You all know what a binary image is. Binary image means there are only two pixels in the image. Those pixels are either the white pixel or the black pixel. Now we know that the appearance of a white pixel as the next observation depends to some extent on whether the current pixel is black or white. Now, how to define that? What will be the next pixel? Let's say current pixel state is black. Now, how do we define that it will be black or white in the next come? So that will somewhat depend on the observation of current state. Okay. Therefore, we can model the pixel process with the help of a discrete time Markov chain model. See, because Markov chain model defines states, so let's see how many states we have. We have two states. Why we have two states? First of all, we have two states because either there is a condition when the pixel is white or there is a condition when the pixel is black. So there are only two states, right? So I define these two states with the help of symbols SW and SB. SW would correspond to the state when the current pixel is white pixel. That is why I have written this is S for state and W for white. So white state, this represents the white state. SB corresponds to the case where the current pixel is a black pixel. That means if I define SB, that means at present the current state of pixel is black. I have black pixel. So these are the two states defining the two pixels. Now, what is transition? Let's say the transition probabilities will be PW by B or PB by W. Now, what does this mean? This means the probability of coming white pixel after the black pixel. And this is what? The probability of coming the black pixel after the white pixel. And the probability of being in each state. This is the probability of having the state W, that is white pixel. And this is the probability of having the state black, that is SB. So let's see how we define the graphical format of this particular Markov model. We have defined two states. This is one state, that is SW, when the pixel is white. This is the other state, second state, that is SB, when the pixel is black. Now, how do we define the transition? See, there are possibilities. If at present I am at white state, there is a probability that again white pixel can come. So if again after white pixel can come, then this is shown with the help of this arrow, because earlier the state was, current state is white and the future state will also be white. So this is the transition. So that defines what? Probability of coming white state after white state. Okay. Now moving to the next, I'm going to find the transition. That is, what if black comes after this white? So the transition, the change of state from white to black. Okay, so what is this? This is the probability of coming the black pixel after the white pixel. So this is what? This is defined as the probability of coming the black pixel after the white pixel. Now next, again, arrow will be shown. After black, there are again two possibilities. First possibility is after white, again black, after black, again white, black can come. So from black to again black, this is the arrow. How do we define it? If we define it as probability of coming black pixel after the black pixel. So this is what? Probability of coming black pixel again, even after the black pixel. And the other says probability of transition from black pixel to white pixel. So this arrow is shown. This is what? Probability of getting white pixel after the black pixel. So this is how we have created the graphical model of transition with the help of discrete time Markov chain model. In this, what we have seen the states, we have seen the transitional probabilities, we have seen the state probabilities. Now what we can find, we can define the entropy, because with the help of model, a good model is said to be good, a model is said to be good only if we can estimate the actual entropy of the model, of the source, then it is termed to be as good model. So we are going to find the entropy, or we are going to estimate the entropy. We all know this is denoted with the help of H, that is the entropy of a finite state process with states Si. Here we have how many states? In the example, we have two states. So S2 is simply the average value of the entropy at each state. So at each state, we can find the entropy by defining this particular formula and keeping the values in this formula. So this is how we define, or this is the graphical format of the Markov model. We can also define it in the equation form. How can we define it in the equation form? It can be in the matrix. We can say that we have state W and we have state black. We have pixel W, we have pixel black. Okay, so we have already seen that there is the probability of white coming after white. So that probability will be written here, that is P W by W. What is this? This is the probability of coming black after the white state. So it will be P getting black after the white. Right? Now here, what it is? Getting white after the black. So probability of getting black after the white. Sorry, probability of getting white after the black. And here, probability of getting black after the black. So it will be B divided by B. So this is the matrix form of this particular model. Here we can put the values of the probability and find the entropy of the source, right? So that's all for this particular lecture. Thank you very much.